Oh, guys. Okay, so the next thing, okay, it says question 6. So we're looking at predator prey in a secluded forest, blah, 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 blah. Anyway, you've got a predator prey, rabbit and fox scenario. Okay. So really what this is testing is that you understand what these formulas mean. So the first thing I would do in this question is rewrite your formula. So immediately then we can see, link things up. So 0.73 must be A. Okay. Your carrying capacity over there must be 5,000. Okay. Your per capita rate of fatal attacks, in other words, B is equal to 0.08. Okay. And the next one, F times B, coefficients of R and Fn. So that over there is FB. So that over there is A. That over there is K. And that over there is F. Okay. Remember, in these formulas, F stands for the fecundity, in other words, the ability to turn food into babies. Okay. So this, and then C is the death rate. Okay. In other words, which is 1 over life expectancy. Okay. B stands for brutality. In other words, the per capita rate of fatal attacks, how successful they are at hunting. So the first question says, what is the average lifespan of a fox? Well, average lifespan is equal to 1 over the death rate. In other words, 1 over C. And in your formula, here, C over there. So this thing over here is C. So it's equal to 1 over 0.2, which is equal to, I would think, 2 over 10, which is equal to 5. Let me just check my mental math is correct. Okay. So it's equal to 5 years, the life expectancy. And it says, what is the per capita rate of deadly attacks? So we are looking for the parameter B. Okay, well, you can't see B from here because that's F times B, but B does appear over here. So B is the per capita rate of fatal attacks, which is 0.08, in other words, 8% success rate. So B is equal to 0.08. Okay. Then they want to know what calculate the efficiency for foxes to turn prey into cubs. Okay, in other words, and that in other words, they're looking for fecundity of the fox, which is F. Okay, F appears only over here on the formula. So this value here is F times B. Okay, let me just close this window. So that you have F times B is equal to this number over here, with this thing over here, which is 0.0000135. Okay, but we know that B is equal to 0.08. So F times 0.08 is equal to this number. So if you divide both sides by 0.08, you can work out F, and you should get an answer of F is equal to 0.001687 times. Okay, so that's just a question of knowing your formula. Remember, this parameter over here represents the total number of rabbits killed by the foxes. Comes up quite a lot in this question. Okay. This, okay, remember it's just your logistic model. Okay. This over here is the total number of foxes killed in a year. With negative coefficients. And this is an increase in foxes, which is proportional to F and B. Okay. Right. Oh, I hate when that happens. Give me a second for that to go away. All right. The next question. Okay. Sorry, I'll come to, give me 5 minutes. Okay. The next question is, you've got to read off these answers over here. So it says, use the graph to estimate. So you've got this spiral plot over here. remember the spiral plot? This is your starting point over here. Okay, the two types of representation. We also get the oscillating plot, which has two graphs of predator and prey. So your model is moving in this direction, and it heads towards equilibrium over here. Remember the distance apart. If the distance between the dots is large, it means the population is oscillating a lot. When the distance between each population cycle becomes small, it means there's not much oscillating. So it's the distance between your dots. So you can see large gaps, settles a bit there, large again, and then settles towards equilibrium. So it says, use a graph to estimate the initial population of both species. Well, this is the initial point here. Where it starts. So it's just a question of dropping your lines down. It's not a bad idea to actually do that on your question paper. So it drops down over there, and it drops down somewhere over there. Okay, there was obviously leeway in that question. And I said the initial population of rabbits is 1,500 rabbits. Okay, roughly I said. Okay, and foxes was around about 14 overall. 14 foxes. So those are your initial values. The stable point, the point of equilibrium, well, it's that value again over there, around about 1,500, and then around about there, looks like about 7. So maybe a bit less. I don't know. There's a bit of error. I said approximately 1,450 rabbits and approximately 7 foxes. Right. So that's just reading off, understanding that graph. Okay. Now, the key idea is equilibrium questions. The first thing is step 1, you always use the fox model, in other words, a predator model, to calculate rabbit equilibrium. Okay? That's step 1. Step 2 is you use a prey model, the rabbit model, okay, and your answer from step 1 to calculate the fox, in other words, the prey equilibrium. Okay, so those are your key ideas. So first of all, we have to work with the fox model, which says fn plus 1 is equal to fn plus 0,001335 Rn fn minus 0,2 fn. Okay, but at equilibrium, fn plus 1 at equilibrium, fn plus 1 is equal to fn. So you're going to end up with fn is equal to fn plus 0,00135 Rn fn minus 0,2 fn. Okay, those fn's will cancel out. So you'll get 0,2 fn is equal to 0,00135 Rn fn. Those fn's then cancel. Okay, and you get Rn is equal to 0,2 divided by this 0,00135 is going to give you your rabbit equilibrium. Okay, and you end up with a rabbit equilibrium of 1,481. Okay, 1,481,5. Okay, is equal to the rabbit equilibrium. Okay. Right, so between 1,481 and 1,482. Then to get your fox equilibrium, we use the other model. Where's the opposite model that you use? So to get the fox equilibrium, we're going to use a rabbit model, and we're going to use the fact that Rn plus 1 is equal to Rn at equilibrium. We're going to use this formula over here, but I'm going to immediately let Rn plus 1 be equal to Rn. So you've got Rn is equal to Rn plus 0,73 Rn, 1 minus 1 minus Rn over 5,000. 1 minus Rn over 5,000 minus 0,08 Rn Fn. But now, so these Rn's will disappear. I'm going to move that to the other side. So I get 0,08 Rn Fn is equal to 0,73 Rn 1 minus Rn over 5,000. These Rn's over here then cancel out. Okay, so Fn, which we're trying to isolate, Fox equilibrium, will be equal to something over 0.08, divide by that 0.08. So I'm going to have 0.73. And then I need to know this is the equilibrium population of the rabbits, which we've calculated as 1,481,5. So I get 1 minus 1,481,5, okay, over 5,000. Okay, all divided by 0.08, and you should get an answer of approximately 7 dollars. Okay, guys.